So from our next class onwards, we will be having offline classes. And
Sir, I have to ask you something about this. Yesterday, I asked our SNC sir, but he told that you are the interim HOD, so to contact you. So, sir, when will be the classes of civil engineering be starting?
actually, as per university guideline, university notification issued yesterday, we are supposed to uh, take classes in offline mode from 7th onwards, because 3rd is tomorrow is 3rd, and day after tomorrow 4th is holiday, 5th, 6th, Saturday and Sunday. So we'll be having classes from 7th onwards, and that will be in offline mode. But for the first week, that is from 7th to 14th, we are likely to have some sorts of uh, lenience in terms of offline classes, because um we should be very much flexible in that sense, that we are assuming that students who are staying away from Jadavpur, that is in remote areas, they will take some time to come to university, to their respective hostels or their local residents. So that will take time. So considering that, the first week we will be having some sorts of flexibility. That means we can go in hybrid mode class, go for hybrid mode class. That is, some classes may be offline, some classes may be on online mode. So that will be actually arranged in consultation with you. But as per university guideline, you are supposed to attend classes from 7. So those who are staying away from Jadavpur, rather away from Kolkata, they are supposed to come to their respective hostels or messes. So and from 14th onwards, you can take that everything will be in offline mode. But from 7 to 14, we'll be having some sorts of flexibility in terms of online, offline classes. So there will be most expected is that there will be some hybrid mode of classes. Okay,
Okay, sir.
you talk to respective class teachers for the first week, whether they will be preferring online or offline classes. But for my class, in next Wednesday, I will be taking offline mode class. So, in fact, today there will be some introductory discussion on surveying 2, and from next class onwards, we will be having offline mode classes. But you can talk to your respective teachers of different subjects. Okay. So let us go through the note. Actually, I have shared in Google Classroom my class notes, although I should not say that is the only resource that you should consult, because usually I prefer to discuss in details in the class, but you need to go through some textbooks also. So let me go through the syllabus first. So surveying 2, this is 3 credits course, and you can find, I think, is it legible? Can you see it?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So surveying 2, the first part that I'll be discussing will consist of setting out of circular curves, setting out of curves, basically different types of curve. There will be other portions like hydrographic surveying and tunnel surveying. Now, in course of your surveying 1, actually you have gone through very elementary aspects of different branches of surveying, different types of surveying, say for instance chain, compass surveying, plane table surveying, leveling, to some extent tachyometric surveying. So all the basic or fundamental parts of surveying you have already dealt with. Now regarding surveying 2, the first part that I will be discussing will consist of setting out of curves, tunnel survey, and hydrographic survey. and rest of the portion will be covered by Dr. Abhishek Roy and Professor Gopinath Bhandari. So obviously, in course of this surveying too, we'll be having some discussion on some very uh, little bit complicated aspects of surveying, or rather some modern methods of surveying. However, the part that is setting out of curve is also, is we can say that it is some kind of fundamental part of surveying, because this is uh, inevitably required in course of highway surveying as well as railway engineering. So I would like to prefer these reference books. Advanced surveying, you can find it in plenitude in our departmental library, authored by Shom and Ghosh. Both of them were our respected professors, Professor Piyush Shom and Professor Bholanath Ghosh. They were the stalwarts of civil engineering department of Jadavpur University. So it is actually a Tata McGrail publications, Advanced Surveying by Shom and Ghosh. Then I would like to recommend two more recently introduced, recently published surveying books, Surveying and Leveling by R. Subramaniam, and Textbook of Surveying by C. Venkatramaya. Another book authored by Professor Alok De. Again, he was also a renowned professor of our Department of Civil Engineering. The book Plain Surveying. Other than these four books, you can go through very elementary books like Kanetkar and Kulkarni, like Kochar. These things will be mostly required for numerical problems, but for fundamentals and theoretical knowledge in regard of surveying, you need to consult Advanced Surveying and Surveying and Leveling, these two books. Now, my part will be actually comprise. This is not 40. Actually, that will be actually set in later part of our semester. That what will be the number allocation for different three different parts. Now let us start with setting out of curves. Now, as I've mentioned that this particular branch of surveying, that is setting out of curves or curve setting out, is very much inevitable in connection with the construction of highways and railways and canals, because you cannot expect that we'll be reaching our destination in the case of highway or railway, or even in the case of canal construction, in a very in a straight way. That is, from one point to another point. If we want to travel by highway or by railway, or if we want to go for design of canal, then you cannot expect that everything will be along a very straight path. So there will be obviously lots of curvature, lots of twist in course of this this journey from a particular point to the next point. So these curves are usually provided in lines of communication in order to ensure a gradual change in direction. It is very important thing that we need to ensure a gradual change in direction. Because, say for instance, if we consider two straight paths, they are intersecting each other at a particular point, then if we need to follow this straight path, at the point of intersection we'll be having a very sudden or abrupt change. If we say, for instance, if we travel from this point to the second point along another straight line, then at the point of intersection, at this point, we'll be having a sudden change in direction. And this abrupt change in direction is very much objectionable in the case of highway or railway, or even in the case of canal. Why? So if we have to understand that what is the significance of the curve. We know that curve is provided in lines of communication in order to ensure a gradual change in the direction. But we need to understand the significance of curve, because it is quite obvious that in the case of highway, railway or canal, we cannot reach their respective destinations straightway. And due to several reasons, uh, these highways or railways have to change their path along their respective direction. And uh, if we have any such sharp intersection, and that sharp intersection like this one can be considered as um, as a curve having infinitesimally small radius. So any sharp intersection can be considered as a curve, a very small curve, or preferably circular curve, having infinitesimally small radius, whose r is significantly low. So what will happen if we have a significantly low value of radius? So this the corresponding figure, you can consider a sharp intersection as a curve having a significantly small radius. So what will happen that whenever a particular vehicle or locomotive in the case of railway engineering will negotiate such sharp intersection, which can be considered as a curve having infinitesimally small radius, then obviously it will experience a significantly large centrifugal acceleration, or in other words, you can say significantly large centrifugal force, because whenever we'll be negotiating any sharp intersection, whenever we'll be moving along a curved path, then what will happen? We'll be experiencing a centrifugal force, and that will be responsible for causing centrifugal acceleration. Now, what is the expression corresponding to centrifugal acceleration? If the centrifugal force is mv square by r, then the centrifugal acceleration component will be v square by r. Now, if we have infinitesimally small radius, then the magnitude of v square by r will be infinitely large. In other words, the vehicle or locomotive will experience suddenly or instantaneously a very high value of centrifugal force. Now, if we just consider this fact that we will be traveling from civil engineering department to production engineering department along the road in our university. So what will happen? So just at the junction of say for instance our FETSU office, at that point there will be we have to take a sudden turn, and if we just walk, that will not be very much difficult for us, because during walking the walking speed is very low. But if we travel by motorcycle, by bike or scooter, or by any private car, what will happen? That if the vehicular speed is very high, then the v square by r, this component will be also significantly high. So we have two options basically. Either we have to increase the radius of curvature considerably to bring down the value of centrifugal force, or we have to reduce the vehicular speed considerably. So that you can easily understand that when we negotiate any curved path, or when we negotiate any sharp intersection, it is very customary that we are supposed to reduce the vehicular speed considerably. Because in that case, v square by r will also get reduced considerably. So the centrifugal force in that case will be reduced largely if we can reduce the vehicular speed in a considerable manner. So in that case, if we neither go for reducing the vehicular speed, or if we do not increase the radius of curvature, then what will happen? The vehicle or locomotive will experience infinitely large centrifugal force, and that will produce a jolt in the vehicles, and it will reduce the comfort of the passengers, and under extreme circumstances that will lead to accidents, because you can find in large number of cases, if we can find that uh, if we want to negotiate such kind of sharp intersection, maintaining at a very high velocity, then there is every possibility to have an accident. In the case of canal, high magnitude of thrust will be produced by the moving water at the sharp intersection, and that will ultimately cause erosion of the canal banks. So, for these reasons, that means in the case of highway and railway, in order to reduce the magnitude of jolt, in order to reduce, in order to maintain the degree of comfort of the passengers, and in order to avoid chances of accidents, and in the case of canal construction, if we want to reduce the magnitude of the thrust produced by moving water, we need to provide curves in between two endpoints, that is in between two straight paths of highways and railways and canals, to change the direction in a very gradual manner. So now we can understand that what is the significance of a provision of curve. Now curves can be basically classified into two types: horizontal curves, that is provided on the horizontal, in the horizontal plane, and vertical curves. As the name suggests, we are supposed to provide vertical curves in vertical plane. Now, although when we'll be discussing, say for instance, with this particular online presentation, or when we'll be discussing in offline mode on the blackboard, we will be drawing the figures on the vertical plane, that is on the blackboard. When we'll be drawing the curves, they are all supposed to be drawn on the vertical plane. But when we'll be considering the application of these curves, we need to consider that by and large these curves are supposed to be provided in horizontal plane. So these horizontal curves can be again classified into following types: simple circular curve, compound curve, reverse curve, diversion curve, and transition curves. So we'll be discussing on these different curves one by one. On the other hand, vertical curves can be classified into two types: summit curve, and number two is valley curve. So these are two broad classification of vertical curves. So we will start our discussion with horizontal curves. And the first one that we will be discussing is simple circular curve or simple curve. Now this is a very typical figure. And in this connection, we will be discussing on different nomenclature associated with setting out of simple curve. Now here you can find that this is the point of commencement of the simple circular curve, that is point A, and the end point is B. Actually, we are supposed to have two straight paths. They are intersecting at the common point of intersection. This is M. And if we need to follow these straight paths, what will happen? We have to travel from A to M. Then we'll be having a sudden change in the direction, and then we'll be traveling along MB. But in order to avoid this kind of sudden change in direction, we are supposed to provide a simple circular curve between A and B, so that we will be having a gradual change in the direction. Now, this point A is called also first tangent point or rear tangent point, or in other words TC, that is tangent curve point, because from A we'll be actually commencing the simple circular curve. So that is the point of commencement. So from tangent to curve we are now moving.
AM be the tangent of the curve at that point.
AM is the tangent at the point A, and this tangent is called rear tangent or backward tangent. Yes. Pardon?
Okay, sir.
This point
Yes,
is
the
called,
A is the tangent of the curve basically.
yes, at the point A, that is a point of commencement of the simple circular curve, we will be having a tangent, that is AM. Because whenever we will be providing any curve in between two straight paths intersecting with each other, we are supposed to provide this curve tangentially. So at the point of commencement of the curve, obviously the rear tangent or backward tangent will be tangent to the curve at the point of commencement. Similarly, on the other end, that is point B, at this point, the tangent, that is MB, that will be called as the forward tangent. Now, we will be discussing on some associated nomenclature. So this is a simple circular curve. That means there will be radius OA is equal to OB, with O being the center of the curvature for the circular curve ACB. Now let us go through some associated nomenclature. So simple circular curve can be defined as a circular curve fitted tangentially between two straights. In between two fixed straights, we can provide numerous circular arcs having different radii. Say for instance, in between AM and MB, we can provide ACB a circular curve, and this one is another circular curve, although it is provided in some at some other distance from this particular point A. So, but we can provide this circular curve, n number of circular curve between two straight paths. So their tangent length will be different, their tangent point of tangency will be different, but only thing is that this particular angle I is equal to delta will be unchanged, will remain constant. Now, what are the associated nomenclature? The first important point is called vertex or point of intersection, that is M. What do you mean by vertex? This is a point of intersection of two straight paths. This is the point of intersection of two straight paths. It is a meeting point of two straights, AM and MB, from which there will be change in the direction of the tangent. So from which there will be change in the direction of the tangent. That is, we will be traveling from A to M, and then there will be a change in the direction of the tangent from AM, then it will be MB. Number two, angle of intersection. Which one? The angle of intersection is angle BMY. That is the angle by which the forward tangent deviates from the backward tangent. If this forward tangent doesn't deviate from the backward tangent, then this magnitude I will be 0. It will be along MY. So this is the angle of intersection I. Now in some textbook, you can find that this particular angle, 180 degree minus I, as shown in this figure, is considered as I, whereas this angle of deflection or deflection angle or angle of intersection, this is considered as delta. So you should not get confused with these terminologies. We should follow a standard terminology. You can call it either delta or I. If this is I or delta, this angle will be 180 degree minus I. Now, if we consider this angle as I, then...
Sir, what you are telling that 180 minus delta, it would equals to I in some books.
In some book, you can find that this angle, just look at the cursor.
Yes, it will
this
be
angle
delta.
is termed as delta, and that is called deflection angle. And this angle, which is shown here as 180 degree minus I, is called I.
Means 180 degree minus delta is equals to I in some books.
In some book, you can find this one is delta and this one is I. 180 degree, instead of 180 degree minus I, they have mentioned is that I, that is I plus delta is equal to 180 degree. But here we are following different nomenclature. we are considering this angle as I. This is angle of intersection by which the forward tangent, this is the angle by which the forward tangent deviates from the backward tangent. If it doesn't deviate, that means if the forward tangent doesn't deviate from backward tangent, then I will be 0. It will be along my. But that is not happening here. We are having some sorts of deviation, some sorts of departure. So we will be having this angle of intersection as I, and here this angle will be 180 degree minus I. So let us follow this nomenclature, I and 180 degree minus I. But for the sake of your understanding, I have mentioned that I is equal to delta, because in some book you can find instead of I they have considered delta, and this one is 180 degree minus delta. Now if this is I and this one is 180 degree minus I, then what will happen? What will be this angle MAB and MBA? This will be actually isosceles. MAB will be isosceles. So in that case, so isosceles will be having this angle equal to I by 2. So MAB is equal to MBA is equal to I by 2. And if this angle is I by 2, now we know that the angle between tangent and radius is 90 degree. So this angle, total angle is 90 degree. So if this one is 180 degree minus I, this one is 90, and this one is also 90, then what will be the magnitude of this angle? This is called central angle. That is angle subtended by the circular curve at its center is equal to the angle of intersection. That is called also central angle. So central angle is also I. This one is 180 because summation of these 4 angles will be 360 degree. So if this one is 180 degree minus I, these two is 90 degree each, then this angle will be obviously I. So central angle will be I. Now we have actually, so this is angle of intersection. Now we have to consider this nomenclature, that is whether the curve will be right-handed one or left-handed one. Now if the direction of progress is from A to B, that is while setting out the curve, if we move from A to B, then it will be right-handed curve because we are moving from left to right. On the other hand, if we progress from B to A, then it will be left-handed curve. So nomenclatures will also change in most of the cases accordingly. Say for instance, if our direction of progress is from A to B, then the tangent at the point A is called backward tangent or rear tangent or first tangent. They are all synonymous. And the corresponding point A is called first tangent point or rear tangent point or tangent curve point, because we are traveling from tangent to curve at this particular point. On the other hand, where the simple circular curve will terminate, that point of tangency is, that is the point B as shown in the figure, is called curve tangent point because we are traveling from curve to the tangent again. Or it is called second tangent point, or it will be also termed as forward tangent point. And in that case, the tangent BM is called forward tangent. Now, in the case of left-handed curve, that is, if we travel from B to A, the nomenclature will change. This one will be B will be TC point, A will be CT point, the tangent BM will be rear tangent or backward tangent, and the tangent AM will be forward tangent. But for the sake of convenience, we are assuming that we will deal with right-handed curve. Suppose in your section B, how many of you used to write in left hand? Very few numbers, I presume. So right-handed curve is relatively conventional from the setting out point of view. So we'll be considering this particular convention, that we'll be considering from now onwards right-handed curve, that is we'll be traveling from A to B, and that will be in a clockwise direction. So with this, we can say that when we have defined right-handed curve or left-handed curve, accordingly we'll be considering forward tangent and backward or rear tangent. So in the case of, we have to mention that in the case of right-handed curve, the point of tangency from which the curve starts propagating is called backward tangent point. It is also called first tangent point and tangent curve point. On the other hand, where the curve terminates is called forward tangent point or rear tangent point or curve tangent point or second tangent point. They are all synonymous. So the tangent passing through forward and backward tangent points are called forward and backward tangents. Now comes few more important terms. The first one is long chord length. Long chord length means it is basically the straight line distance between two tangent points. The straight line distance between two tangent points you can find, that is between A and B. We can have a distance measured along the curve, that is actually curve length. But when we'll be measuring the straight line distance between A and B, that is called long chord, because a particular curve may have several chords, but out of these different chords, the maximum length will be of the long chord. This is the largest chord of all chords. This is this particular chord has got large maximum distance, largest distance, that is from A to B. So this is called long chord. And long chord distance or long chord length. Then curve length, this is the length of the curve measured along the circular arc in between two tangent points. And what is the apex of the curve? It is the midpoint of the circular arc, which is called summit or apex. So if we, this particular point C, it is the midpoint of the circular arc and it is called summit or apex of the curve. Similarly, we'll be having two more important terms. Apex distance or external distance. It is defined as a distance between vertex and apex. So if we just measure the straight line distance between the vertex point M, which is basically the point of intersection of two tangents, and the apex, that is the midpoint of the circular curve, then we'll call it apex distance or external distance. Then comes mid-ordinate distance. It is the distance between midpoint of the long chord and the apex of the curve. So midpoint of the long chord AB, that is N, and the apex C. So if we consider this distance Cn, that will be the mid-ordinate distance. You have to remember all these terminologies. Mid-ordinate distance, and we have already discussed on the central angle, that is the angle subtended by circular arc at its center. So these are different nomenclature associated with setting out of a simple circular curve. Now comes the question of how to designate a simple circular curve. Now we can designate a simple circular curve by any one of the following. Number one, by radius of the circular curve. Say for instance, if you have a circular curve having 200-meter radius, we can designate it as a circular curve having 200-meter radius. So this is a way of designating a particular circular curve. One of the means of designating a simple circular curve. Number two, degree of the curve based on fixed arc length. Degree of the curve means, that is, we can define that it is an angle subtended by a fixed length of the circular curve at its center. It is a standard practice to consider this fixed length as 30 meters. So that means when we'll be defining degree of the curve based on fixed arc length, it will be the angle subtended by the 30-meter length of the curve at its center. So this is termed as dA. dA, at the suffix we have A means arc length, fixed arc length, dA degree. So we can have the expression dA degree means, we know that degree of the curve, the angle subtended at the center, is equal to arc length divided by radius. Now what is the length of the arc? That is 30, and radius is r. But if we supposed to express it in degree, then we have to multiply it by 180 and divide it by pi. So the expression corresponding to degree of the curve based on fixed arc length is dA is equal to 1718.9 divided by r. The second one, the third one rather, that is degree of curve based on fixed chord length. Since we are using term fixed chord length, we are considering this expression dc. So dc degree is a fixed chord length. This is defined as an angle subtended by a chord having fixed length, that is 30 meter. Now here, instead of having fixed arc length of 30 meter, in this case, we are having fixed chord length of 30 meter. So what will be the angle subtended by that particular arc having fixed chord length of 30 meter at the center of the curve? So here, as per the figure, AB is equal to 30 meter. That is AC, C will be the midpoint, is equal to CB is equal to 15 meter. So the angle COB, now C will be this midpoint. It is not the apex point. C will be the midpoint. So COB is equal to AOC is equal to DC by 2. If this total angle is DC, then each segment will be DC by 2. So if we consider any particular triangle, OBC or OAC, then we can write BC by OB. BC by OB is equal to sine DC by 2. So sine DC by 2, BC is 15 meter and OB is R. So sine DC by 2 is equal to 15 by R, or in other words, DC is equal to 2 sine inverse 15 by R. And we'll conclude our discussion with this element of the simple curve. Element means it basically the parameters which describe the configuration of the simple curve with respect to straights. Parameters describing the configuration of a simple curve with respect to straights. Now these straights are fixed, but it will be describing, now in between this straight we can provide simple circular curve having different radii. Now if you just try to understand that what are the sets of points required to describe a simple circular curve uniquely with respect to the straights, we have basically two sets of points. Either we can set it by these 4 points M, A, N, B. That means we will be proceeding from the vertex M, then we will be coming to the point of tangency, then we will be traveling along the curve and occupy the apex portion N, and then coming to this point, that is second tangent point B, M, A, N, B. Or we can proceed from the center of curvature, that is O, to A, then N, B. So there are two sets of points, M, A, N, B and O, A, N, B. Now, so this is set 1 point, set 2 point. Now, if we consider these two sets, in both cases, we will be having that certain parameters will emerge out to be significant in describing the simple circular curve. So these are actually 7 parameters which can describe the curve, simple circular curve uniquely with respect to the straights. Number 1, tangent length T, long chord length C, curve length L, mid-ordinate distance M, external distance or apex distance E, radius of curvature R, and angle of intersection I. So just for the sake of keeping it into memory, you can say TCLMERI. These are 7 elements of a simple circular curve by virtue of which we can describe the curve uniquely with respect to its straights. Now again, we'll find a very interesting thing, that is we can express TCLME, these 5 elements, in terms of R and I, the rest of 2 elements. Say for instance, tangent length T. Now, if we consider the tangent length, I think from this point onwards, we need to discuss in offline mode because we have to derive certain things. And in our next class, we'll start from this point. That is, we have defined elements, but we need to derive the expressions for different elements of simple circular curve. So for the time being, let us conclude this discussion at this point because we have to derive certain things. That is, we have 7 elements which can describe uniquely the simple circular curve with respect to the configuration of simple circular curve with respect to its states. But interestingly, we'll be able to describe or define first 5 elements with respect to the rest 2 elements, that is radius of curvature and angle of intersection. আমি এইখানে থামছি এই কারণে, এরপর আমি ওই ছবিটা এঁকে ডেরিভেশন গুলো সবকটার করব এবং সেটা ক্লাসে আমরা অফলাইন মোডেই করব নেক্সট উইক, নেক্সট ওয়েডনেসডে।
স্যার একটা জিনিস জিজ্ঞেস করার আছে।
হ্যাঁ বলো।
স্যার আপনি কি এই পিডিএফটা একটু পাঠাতে পারবেন? সব পয়েন্টস গুলো নোট ডাউন করতে পারি এনি টাইমে।
এগুলো গুগল ক্লাসরুমে আছে।
ক্লাসরুমে দেওয়া আছে বাবা।
ওকে স্যার, দেখে নেব আমি সেটা।
ওখান
থ্যাংক
থেকে
ইউ।
সবাই ডাউনলোড করে রাখতে পারো। তবে আমি বলবো, দেখো, আন্ডার প্যান্ডেমিক সার্কামস্টান্সেস উই নিড টু কালেক্ট দিস কাইন্ড অফ ক্লাস নোট ফ্রম আওয়ার স্টুডেন্টস। মানে আমাদের ক্লাস নোটটা তো টাইপ করা সবসময় থাকে না, ফলে সেটাকে থেকে যদি আমি কোনো একটা স্ক্যান করতে চাইতাম খুব অস্পষ্ট আসতো। সেই জন্য এটা নিজে, এর মধ্যে অনেক ভুল ত্রুটি আছে, আমি এটা দিয়ে দিয়েছি। জাস্ট যদি কেউ কোনো ক্লাস নোট মিস করো, ইউ ক্যান কনসিডার, but I should like to prescribe that you should follow my class. And also, as I've mentioned few textbooks in regard of surveying 2, you should also consider the theoretical portions or numerical portions of these textbooks for your further study. Next class onwards আমরা অফলাইন মোডে নেব, যেহেতু তোমাদের আলাদা আলাদা করে সেকশন, তোমরা একটু ডিস্টেন্স মেনটেন করে বসবে, কোভিড প্রোটোকলটা মেনটেন করে বসবে, মাস্ক পরে আসতে হবে এবং সঙ্গে স্যানিটাইজার ক্যারি করবে, এইটুকু প্রিকশন নিয়ে আসবে। তারপর আমরা অফলাইন মোডে রেগুলার বেসিসে ক্লাসটা নেব। আর এই ক্লাস নোটটা তোমরা গুগল ক্লাসরুম থেকে ইউ ক্যান ডাউনলোড।
স্যার একটা কোশ্চেন আছে।
হ্যাঁ বলো।
স্যার আপনি যে এখানে পড়াছিলেন সিম্পল স্যার এই কার্ভে, যখন ওখানে আসেন স্যার একটু ওঠান, আমি একটু পয়েন্ট, ওখানে একটা 30 মিটার একটা আর্ক ছিল স্যার।
হ্যাঁ,
ওটা কি 30 মিটারটাই তো ওটা থেকে ভেরিয়েবল হবে নাকি? মানে 30 মিটার ধরেই তো করা হয়েছে, মানে এটা মানে
এটা যখন এটা হচ্ছে স্ট্যান্ডার্ডাইজ করা হয়েছে, এই যে কথাটা বললাম ডেজিগনেশন অফ এ কার্ভ, মানে আমরা ডেজিগনেশন মানে কি, ধরো আমার ডেজিগনেশন হচ্ছে আমি প্রফেসর, একটা কার্ভেরও তো ডেজিগনেশন থাকবে। কার্ভটাকে কিভাবে ডাকতে পারি? এনি ওয়ান অফ দ্য ফলোইং, এই যে 3টে ওয়ে আছে, আমরা ওকে হয় বলতে পারি দ্যাট ইজ 200 মিটার কার্ভ or 150 মিটার কার্ভ or 250 মিটার কার্ভ লাইক দিস, অথবা ডিগ্রি অফ কার্ভ। ডিগ্রি অফ কার্ভ মানে বলতে পারি 7.5 ডিগ্রি কার্ভ, কিন্তু বলে দিতে হবে whether it is based on fixed arc length or fixed chord length, that you should mention.
মানে
এবার যখনই
30 মিটার
বলছি
ক্যান বি
fixed
ভেরিয়েবল,
chord
ইট ক্যান বি 200 মিটার অলসো, ইট ক্যান বি 150 অলসো, ইট ক্যান বি এনিথিং।
yes, এর লেন্থটা, এর অরিজিনাল টোটাল লেন্থটা, দ্যাট মে বি এনি ভ্যালু, দ্যাট মে হ্যাভ এনি ভ্যালু, 150 মিটার, 250 মিটার, 200 মিটার, 180 মিটার, like this. But when we'll be defining its degree of curve based on fixed arc length or chord length, we'll be considering that in the case of fixed arc length, that what angle it is going to make with respect to its center, that is an angle made by 30 meter length of that curve. যদি তার লেন্থ 200 মিটার হয়,
সেটাকে 30 মিটারের রেসপেক্টে নিয়েছে, তারপরে আমি
30 মিটার,
অ্যাঙ্গেলটা বের করব।
30 মিটার একটা সেগমেন্ট, সে সেন্টারে কত অ্যাঙ্গেল করছে, সেটাই হচ্ছে বাই দিস ইজ স্ট্যান্ডার্ড কনভেনশন।
মানে ওটা 200 থাকলে ওটা 30 মিটার পোরশনটা কতটা কার্ভ তৈরি করছে,
কতটা কার্ভ, দ্যাটস রাইট। সিমিলারলি ফিক্সড কর্ড লেন্থ যখন বলবো, তার 30 মিটার লেন্থ কর্ডটা কতটা অ্যাঙ্গেল করছে, এখন 30 মিটার কর্ডটা অ্যালং ইটস ডিফারেন্ট লেন্থ, মানে গোটা লেন্থে বিভিন্ন পয়েন্টে একই অ্যাঙ্গেল করবে।
স্যার 30 মিটার হিসাবে কেন নেওয়া হচ্ছে? মানে
এটা স্ট্যান্ডার্ড প্র্যাকটিস, এই কারণে আমাদের দেশেও স্ট্যান্ডার্ড প্র্যাকটিস এটা, এই কারণে 30 মিটারটা হচ্ছে একটা টেপের লেন্থ হয় অনেক সময়।
ওকে,
সেই
মেজারিং টেপের লেন্থ অনুযায়ী এটাকে করা হয়েছে স্ট্যান্ডার্ডাইজ।
এটা স্ট্যান্ডার্ড প্র্যাকটিস, এটা কনভেনশন। এটা কেন ওরকম, মানে এরকম একটা আমি উদাহরণ দিলাম, আমাকে 30 মিটার লেন্থের টেপ পাওয়া যায়।
ওকে স্যার, ওকে স্যার,
ঠিক আছে। আমি এখানে থামলাম এই কারণে, আমাদের প্রথমত তোমাদের তো 12টা বেজে গেছে, এখন আরেকটা ক্লাস এসে যাবে তোমাদের, হচ্ছে যে এই এরপর ডেরিভেশন গুলো করাবো সবকটা, সেটা একটু ক্লাসে করার সুবিধা, কারণ এই বারবার এই ওপর কার্সার ওপর নিচু করে করে এই ঠিক সুবিধার নয় আর কি। প্রত্যেকটা এখানে তো প্রত্যেকটা পাতাতেই ছবি লেখা নেই তো, ফলে ছবিটা আঁকা নেই বলে এটা অসুবিধা হবে একটুখানি। মুখে মুখে বলে গেলে হবে না, ওটা একটুখানি ছবি এঁকে এঁকে বোঝাতে হবে। ঠিক আছে, নেক্সট ডে আমরা এখান থেকে শুরু করব, এলিমেন্টস থেকে একটু ডিসকাশন শুরু করে তারপর আমরা মেথড গুলোতে চলে যাব, সেটিং আউট।
Okay, sir.
Okay, so get ready for offline classes with due precautions.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.